Hi everyone, today we're going to be looking at the Arduino Uno Super Starter Kit digital inputs. Now, detailed information contained in the video can be found at accautomation.ca. The link's been put in the description below. If you have not watched the other videos yet, there'll be links in the description below that will start you at video 1. There'll be links to the rest of the videos in the series as well. So we'll be looking at using push buttons to turn LEDs on and off, and this will be programmed using our Arduino Uno R3 from our Super Starter Kit. Now, push buttons will allow actions to be performed that our Arduino program sketch will interpret and take action. Now, we will be wiring two push button switches. A pull down resistor will be wired to the first switch and a pull up resistor will be wired to the second switch. This will change the state of the input to a high or low based on the wiring. Now, two LEDs will be wired to the outputs of the Arduino Uno, and this will show the state of the switches and allow the switch inputs to modify the state of the LED. We'll be looking at different types of programs, and eliminating switch bounce will also be discussed and programmed using our Arduino Uno Super Starter Kit. So what we'll do is take a look first of all at our switches, and switches are a simple mechanical device that will connect two contacts together with a press of a button or a flip of a lever. And this is actually our switch here that we're showing, and in fact we have 4 different pins on here, which is kind of confusing, but if we look at the actual wiring diagrams, you'll see that A and D and B and C are connected. So when we hit the switch or put some pressure on there, it joins these two together, so everything then gets contacted together. So that creates our switch itself. So let's, and then when we wire that to our Arduino Uno, here is what we look like. So you'll see you will have, in this case here, we have a pull down resistor for our first switch here. And that first switch is actually going to pin number 9. And then we have a pull up resistor here, which is going to pin number 8. So let's just call up our hardware and take a look at it. So here it is right now. So there's the actual switch, and you see the 4 different pins, and on the back of that you will notice that you'll see these little bars. Those bars across it indicate that those 2 pins are actually connected. So those 2 bars indicate that those 2 pins will connect to those 2 pins once the push button is selected. So let's just move that pin out of the way, the switch out of the way. And this first push button switch you see here, and this is my pull down resistor. So it's actually connected to my ground right there, as we see up here on my drawing. And then my second one is connected to my pull-up resistor right there. So if we are connected to our pull-down resistor, so if no one touches the switch, it actually sits at 0 volts, or this will be a low signal coming into the first one. If it's a pull-up resistor, you see that we're connected to the positive 5 volt DC. So it actually receives a 1 or a high value in that location. If we look at our LED wiring, you'll see our LEDs, they're connected to pin number 5 and pin number 4 respectively. And this is the same diagram we did previously. So let's take a look at our first Arduino sketch or program. Here it is right here. And what we're going to do in this sketch is basically just mimic the input of our LED light itself. So here's my button A input going to pin number 9, my LED 5 or LED 5 pin going to pin number 5, button B going to pin 8, and LED 4 going to pin 4. So I just declare my pin numbers there. Then what we do is we set up and run once our setup instruction. So what we're doing is we're saying pin A or button A or push button A is our input, button B is our input, and we have LED 5 and LED 4 pin are both outputs. Then what we do is we run consistently. So we say if the digital read, the input button, is high, then what we do is turn pin 5 high, else we turn pin 5 low. So this is either going to set the LED high or low depending on what that input condition or the state of that input will be in that push button input. Then our next second if else statement, we have if the button B is equal to high, then we turn on for high, else we turn for low. So that is our complete program. So it just mimics whatever our input is, the output is. So let's plug this Arduino Uno in. You see here we powered it up, and we have currently we just have a blinking light here. So what we'll do is we will send this sketch over to our actual unit itself. So we'll upload. So it's going to upload that to our sketch unit. It'll just take a second or two. There we go. Upload's complete now. So now, as we run this program, you will see currently right now, because we have it wired, this one's low, so the first LED light is low. This one is wired high because it's a pull-up resistor, and it's wired and it's showing high. So if I were to select my input, turn it on, for my B, it goes on. So it's actually mimicking exactly what's happening on that first input. The second one does the exact same. So right now it's off, so it's high. Energize it, closing that contacts, and it goes low. So that is my first sketch. Now for my second sketch, let's take a look at it now. And what we're going to do in this sketch is basically inverse each of them as I toggle. So my first input will set the LEDs one way, and my second one will turn the LEDs the opposite way. So in other words, one's going to be a start switch, one's going to be a stop switch. And whether the logic is on or off really is dependent on how I want to get that wired. So I've shown both states so that when one pin is, or when the first pin's hit, certain conditions are hit, the next one's hit, the next one's hit. So then we have the button A and the LED blend. Right. So, and then we have our pins. So we indicate our pin modes. Then what we have, we've also indicated at the bottom here, our digital write. So our initial start will be that pin 5 is low and pin 4 is high. So our LED light will be off and on, just like it is right now. Then on our loop, what we do is we say if the first pin is high, so that means it's changed states, then LED 5 is high and LED pin 4 is low. And then we say if the second one, button B or push button B, is down low, because remember it's wired high, then we do the opposites. This is like a start and this is like a stop. And again, our logic depends on how it's actually wired into our Arduino Uno. So that's our sketch. So let's upload that to our controller. There we go. And there, it's finished uploading. So right now what you'll see is there's our normal state. And if I were to hit the first switch here, the opposite switch states occurs. So the first one turns on and the second one turns off. So that's like my start. And then if I hit the second one, it returns it or stop, and that one turns off, that one turns back on. So that is our operation of our switch input, so on off. And then the last what we're going to talk about is our toggle. So if we want both these LED lights to operate independently of each other, and as I hit this push button switch, the button A, the first LED light comes on. If I hit the same button again, LED light A, or the first LED light turns off again. So one button controls each light. So we call that the toggle, and I'll just call that up. Here we go. There's my toggle circuitry. And when we look at toggles, we're actually looking at, because we're using the same one, every switch that we have has a bounce. So every time you press that contact or press that switch, the contacts come together, but they take time to settle into the new position. And the settling can vary. So typically you'll see 1 to 20 milliseconds it takes to settle in. And during that time that you're settling in, the switch is actually what they call bouncing or turning on and off. Now, typically this is anywhere from 1 to 20 milliseconds. And just to give you some perspective, a human eye can catch typically around 200 milliseconds or 1/5 of a second. So this is happening like 10 times faster than we can actually detect in our human eye. But the Arduino Uno can pick that up because of its scan. It's scanning the program very fast and picking that up and then indicating. So what we have to do is we have to delay that code, or write some code to delay that time frame so that it will pick that up. So let's take a look. Again, we indicate our buttons and our pins for them. Then we indicate whether they're high or low currently. And then we have what we call the last state. The current, okay, so we have the LED state. We have to specify it as the output. We have A, and button B state is low. Then we have unassigned long variables because of the time frame, and we have our last bounce A time and last bounce B time, and we let them 0, and our bounce delay is going to be 50 milliseconds. So that's going to be enough time in order to eliminate all that little bouncing, so that when we hit the button once, it turns the light on, hit the button again, it turns the light off. So, and then what we do is we start our setup. So we're just specifying our output points here, and then we're setting our LED output pins to the correct orientation. Then we have our loop. And the first one we're going to do is take a look at switch A. So in switch A, we read that input. And then if the input A is equal to last state, then what we do, if the input A is not equal to the last state, then we set our debounce time to this current milliseconds that the Arduino controller is at. So this millisecond timer basically will tell us how long that unit has been running for since the start. So, and if the milliseconds minus the last debounce time A is greater than debounce delay, then we can do something. And that what we're going to do is actually switch our reading A, and it's not equal to push button B state, then we're going to change those states. So we're going to toggle that back and forth. And then if the button A is not equal to high, then the last state is not equal to 5 state. So that we're just making sure that's okay. Then what we do is we save our readings. So here's where we're actually digitally writing it first of all. Then we save our readings. So next time through the loop, the last button A state is memorized. Then we do the exact same for B, but this time B is the actual inverse logic because we have that pull-up resistor making the state of the logic opposite. So we have our reading B, and if reading B is not equal to the last state of B, then our debounce time again is set to the mils, indicating that we have a change of state here. And then what we do is wait until those mils minus the last debounce time is greater than that debounce delay, which is our 20 milliseconds. Then, or 50 milliseconds, I should say. And then what we do is we do the same type of logic again. In this case here, we look for the B state as not being equal to low. So that means that someone's actually hitting that button. Then we change the state, we write that button. So basically what we're doing is only delaying that time frame for a certain amount of time before we switch it over. So let's upload that program to our Arduino Uno, and then we can give that a try. So our upload's now done. And so if we go back to our controller here, they're both high. So if we toggle the first one, it turns off. Toggle it again, it turns back on. So the first button is controlling our toggle of that first LED switch, or LED. Then our next one, our second push button switch, will toggle the second LED on and off. So one press to turn it off, one press to turn it on. So it just toggles back and forth. So if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click that bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.